Okay, so we are gonna do a quick review. I'm gonna move my face over out of the way. Okay, so you're gonna do these notes first, and then you're gonna do the activity, 6 questions, and then after the activity, then you should try the quiz using these notes and the notes from yesterday. Both sets of notes will be very, very helpful in doing the quiz. Again, the quiz is only open for tomorrow, full day from 8 till 11:55. If you have issues, you need to email me, contact me, use class tag. All right, so we're going to go get to it. In your notes, there is one thing I did want to mention. Somebody mentioned they wanted to write their notes down. Absolutely. I've never said don't do that. If you want to get a notebook and start writing everything down, I suggest it. That's what I do. Even when I'm giving PowerPoints at meetings, I bring a piece of paper or a notebook or something and I start jotting down notes. That's just who I am. That's how I learn. All right, on to the review. Sedimentary rocks. They form from bits and pieces of rocks that are glued together. Not always rocks, but typically rocks. Okay, so this is some forms of sedimentary rocks. And we're looking at where a river kind of like flows out into a lake, the ocean, some big body of water. I'm not sure where they are, but I'm sure in Onondaga Lake they have something similar to this. Okay, usually when it's flowing, you have this faster flow until it gets out into the open. When it gets out into the open, that's where you have a lot of the slowdown because there's not a lot of current going on in lakes. Well, at this point, like compared to the streams and creeks and stuff like that, they're super fast compared to lakes. They don't have as much of a current. So what happens is as it's flowing out, as it's going out so fast and then it starts to drop, the water starts to drop out all these different types of particles, all these sediment particles. And we will go over this in the next unit for weathering and erosion. But for right now, this is great for you guys. So as it goes down, it drops the heaviest stuff first. I don't know if you've ever shook up a bottle with water and like rocks and stuff like that. Usually the heavier stuff hits first. So the first things that drop out are pebbles. And pebbles make conglomerate sedimentary rocks. If you have your reference table like this is the page 7 scheme for sedimentary rock identification. I'm looking at mine, by the way, because I've got mine right here. Always do. All right, so looking at this, we're going to start looking at this size, this land-derived. So pebbles make conglomerate. How you know? Basically, it looks like pebble pudding. And then the next thing you have, the next size down is sand, which makes sandstone. Kind of hope that's that goes 2 and 2 together. The next down you have silt, and that makes siltstone. So if you look at these boxes right here, you're like, Miss Co, what the heck are those? Where did they come from? Well, look at right here, these map symbols. That's where they come from. And yeah, my conglomerate is not like right on. There is differences because I hand wrote these. Okay, so then after sand, you got siltstone. And if you look at this, conglomerate has like dots in it, but with circles. And then we get rid of the circles, the pebbles, and then you're left with sandstone with all the little dots. And now I'm going to go to siltstone, and I'm going to have dot dash dot dash dot dash. And then I'm going to go even farther, and it's even smaller. You're going to have the clay particles, which are dash 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 dash, and that turns into shale sedimentary. Remember, shall not be shiny. Keep that in mind. And then last but not least, you have weird living creatures. Like if it was in the ocean, you'd have these living creatures. Could be crabs and shrimp and lobsters and stuff like that. When they die off, they leave their shells, and the shells start to build on top of each other, and that has calcite in it. And calcite, if you remember from your activity, it bubbles with acid. It's the only one that does it, and it's kind of cool. And as it like smushes down, it makes limestone. That's the one thing I did not have written on here. This is limestone. 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 Okay, and you see this little hint up here. It says glue equals sand and water. So it is compacted, smushed, and cemented. When it's smushed, it smushes and it binds together. It binds together because that water and sand that act like glue ends up cementing. Okay, and then you probably noticed that I have, sorry, I forgot the glue part, caves right here. So limestone forms caves, and these caves do something because calcite bubbles with acid rain. What happens? Oh, pardon me. Oh. The limestone dissolves in essence because it had all this calcite, and what's left over is caves. Okay, I just wanted to show you this, what we were talking about. Here's some comments with the rounded fragments, angular, fine, coarse, very fine, compact, may split easily. You can see the map symbols right there. And these are all classic. Grain size, that's how I find out what size they are. Like these are the bigger ones, and it's getting smaller, smaller, and smallest. It does say what they're made of, but because they're all kind of made of the same thing, you don't really look at composition too much. It's more of what's in the comments and grain size. Now, when we're looking at the chemically and organically, you do look in the comments to see, how is it made? Composition, that definitely goes into what type of rock you have. Like halite always makes rock salt. Gypsum makes rock gypsum. Grain size is given, and there's that texture, how we have the crystalline. That was one of the three. So you got classic, crystalline, and then finally on the bottom you have crystalline and bioclastic, which you can have the limestone or bituminous coal. And all right, some I didn't get. There are 3 types of textures. Classic, which means they are made from sediments glued together, like sandstone, made of sand, all glued together, or conglomerate made of pebbles and or cobbles, and those are glued together. Then there is bioclastic, which means it's made from what was living things glued together. An example is bituminous coal, which is made from plants, non-degraded plants. And then you have limestone, which is made from shells from living things glued together. Then there's crystalline, which are precipitates or evaporates. Just means they've either fallen out of water or they were left after being evaporated. For example, salt water is an evaporate that makes rock salt. So here on yours, this is easier to do if you're like handwriting. Handwrite or hand draw the conglomerate map symbol. Should look like this. Sandstone, that's, remember, the box with the dots. And then we got siltstone, so you're going to have dots and dashes. Every other dot and dash. Then shale, we're going to get rid of those dots altogether and just have dashes. Then limestone, we're going to connect these dashes both ways, across and up and down. It kind of looks like bricks. All right, what mineral is in limestone? So if we go back to this right here, calcite, limestone. Oh, yeah, hold on. Limestone's that way. I went the wrong way. All right. Oh, sorry. Here's what I meant to say. Acid rain dissolves the calcite that is in limestone, and that forms caves. That's how it actually works altogether from the previous page. All right. So what mineral is in rock salt? Well, that's halite. And again, you can find that where it says halite right here. Go over rock salt. In breccia. So you go up to the top and then you look over into the section that I said usually you're not asked. Breccia is made of quartz, feldspar, and clay. Grain size for sandstone. So you're going to look in that column where it says grain size. Sand makes sandstone. So use that grain size, which is 6/1000ths, and it goes to 2/10. All right. Last but not least, I did pictures of these last year. If we were in class, I'd have you like mess with these and touch these and get used to these. So up at the top you have conglomerate. That really does, it's supposed to look like a whole bunch of pebbles glued together. Literally, it looks like pebbles glued together by rock. Breccia, that's where it's the angular, not rounded pebbles, but like angular, sharp cornered stones mixed all together. Sandstone literally looks like sand. And if you get a good piece, it's got different like layer colors. It looks really neat. Siltstone, that tends to be like a grayish or whitish color. It's very fine, like sand. You can kind of feel it feels almost like sandpaper. Siltstone is like a step down from it. They're smaller, not as rough. And then you get shale. Again, shall not be shiny. You can see it right here. It's kind of dull. That's even more fine than siltstone. So that's got like kind of a smooth feel to it. Then you got limestone, and this one is the bioclastic, which is made up of shells. It looks like oatmeal. It looks like oatmeal. Don't ever eat it. You'll break your teeth. But oatmeal. And then you've got bituminous coal. And this coal looks very, very shiny. It typically isn't as shiny as the other stuff. And when you see anthracite, you'll know what I mean. This stuff, you can see it's kind of got like flat layers going on in there. All right, so we're done with the notes. Make sure you have your notes from today and yesterday to take your quiz, which is due at 11:55. I hope you guys have a great day.